Good afternoon. My name is Tristan Blease, and I'm joined here by my colleague, Michael Chang, and we're from Groupon. And we're here to talk to you folks a little bit about the hybrid boundary, which is a project that we've been involved with at Groupon. And we're pretty excited to share with you folks kind of a journey that we're on our way through right now. So Groupon, as it is today, has largely existed in on-prem data centers. Now, today, we are moving our workloads to the cloud. This is a pretty exciting time for us. I think a lot of folks in the audience have probably already been there, done that, but it's been a really great chance for us to kind of reevaluate the things that we're doing and see if those things make sense or not as we migrate and move forward. So now Groupon, if you're not familiar with us, Wikipedia sums it up pretty well. We're an American worldwide e-commerce market. We connect subscribers with merchants, and we have all kinds of activities, travel, goods, and services. And we operate in more than just the US. We're actually in 15 different countries. Now, we're also the third largest e-commerce app in mobile, from what I understand. So if you haven't been to Groupon.com, do yourself a favor. Check it out. See what's changed since you've been there last. Now, before we can talk about moving to the cloud, let's take a look at how we operate today. So Groupon is largely a service-oriented architecture. We went from a monolithic Ruby on Rails application to over 600 different microservices in a pretty small amount of time. Now, most of these services are HTTP-based REST APIs that serve up JSON and consume JSON, and they're implemented with a pretty wide array of different languages and frameworks. Well, most of them, though, today are now being written in Java and Node.js. Now, these services are served up from data centers that are spanning multiple geographic regions. And we have GitOps-based infrastructure management tooling and system in place that helps our teams manage it. Now, all of our service owners are responsible for managing their own infrastructure, and so they do so with the help of different platform teams that are there to provide support, whether it's through load balancing, firewall configuration, or just host management in general. And we do have a pretty healthy mix of both bare metal as well as KVM-based virtual machine infrastructure, too.
Okay, so where do we go from here? Here, how about now? Cool. Sorry, I will repeat. There are two big initiatives inside Groupon to improve our current infrastructure. The first is Go Cloud. There are tons of benefits of using cloud, like it will provide multiple regions and improve the geo-redundancy, of course. And it can scale up and down based on your need. But to be honest, cloud is pretty new to us, and we are carefully. So we at the beginning, we opt in a hybrid model, which can allow us to ease into the public cloud slowly and carefully. And we do want to maintain the stability. So the second initiative here is the Kubernetes. We do want to use that, and you guys probably know better than me, and there are tons of benefits using Kubernetes, like improve the utilization and the orchestration of all the resources. And hey, tomorrow is KubeCon. You guys will definitely learn more about that. And by the way, this presentation will focus on the first one, which is the Go Hybrid. Okay, now we decided to move in a hybrid model. So let's talk about what features or requirement we need here. So in the hybrid model, there are some clusters in the on-premises and some others in the cloud. So the question is, how can we distribute traffic between the on-prem and the cloud? And of course, we're not going to roll out this 100% at day one. So we definitely need some waiting feature to allow us gradually ramp up traffics. Additionally, we want to detect service failure very quickly and fall back to the next available environment if that's available. And it should be automatically. Along the road, we want to avoid manual process. As Tristan mentioned before, our service team own their infrastructure, but they will get some support from the support team, like provisioning VMs or configure like load balancer, DNS firewalls. And many of those processes are done manually today. And of course, it will slow us down. So we're trying to utilize the CI/CD pipeline to automate the provisioning and the deployment of the configurations. And we do want some dashboards and alerts in place automatically to make sure the system is running correctly and the services are meeting their SLOs. And the last one is the security. Many Groupon services require end-to-end encryption to ensure the security and the customer privacy. So we want that in this requirement. And the access control currently is done pretty much by the static IP address. So you may know that may not fit in the very dynamic cloud environment. So we are targeting to enable mutual TLS for access control. And that's pretty much the requirement we want. I'm handing to Tristan to talk about what we want to build.
All right. So given we know what our core requirements are for operating in a hybrid model, let's take a look at the different components that we decided that we will pull in to build up the system. I suspect you're probably going to know at least one of them. All right. So our key actor here is Envoy, and we're really just leaning on Envoy for its core load balancing and proxying capability. Envoy has been battle tested elsewhere at Groupon. We actually are currently using it to handle all of the ingress to Docker containers that are running on our on-prem Mesos clusters today. And it's proven to be a fantastic piece of software for handling that. Super excited to start expanding its usage elsewhere at Groupon and taking on and being able to turn on more capabilities for our developers. Now, we also have with it, too, as well, a support agent. Our control plane is distributed. It runs in sidecars alongside of each of the Envoy instances. And so this support agent, it's written in Golang. It is using the Go control plane to implement the XDS APIs that Envoy requires. And it's also doing a few other things, too, as well. So when this agent comes online, the first thing it does is it goes ahead and it registers the edge proxy node with a NoSQL database up in the cloud. So we use that registry then to find other Envoy instances that are deployed across different availability zones so we can mesh them together and send traffic back and forth. Now, this, as I mentioned also, the support agent contains the configuration for Envoy. So it is also pulling that same NoSQL database, a different table there, to put back the different service configurations that are in place. So it can present that to Envoy, as well as to the other components that we have deployed on-prem for automating away some of the manual process that we're trying to fight as hard as we can to get away from. All right, so I mentioned we're using Cloud NoSQL database. The agent will pull this in a regular interval. We expect everything will be eventually consistent and wonderful. So far in our testing, it's worked out pretty well. We also use Cloud DNS and Cloud Load Balancing. So we have requirements on our host names that we use for TLS and connecting to things. And so we do leverage the Cloud DNS in our cloud environments, and then we also use the load balancing features that are available there because we can automate those pretty simply. Now, as far as the build and deployment automation, we're just using Jenkins. Pretty boring, but it gets the job done. And then we're deploying everything inside of Docker containers today with the intent of eventually moving that on top of Kubernetes directly. But for now, we're just deploying that on top of compute instances. We do use Wavefront, which is a time series visualization tool. All of our metrics flow there. And so that's the place where we do all of the visualization for metrics that are flowing out of Envoy instances, out of our support agents, and all the other infrastructure pieces that are involved here. All right. Now, additionally, we do use Bird, the Bird Internet Router daemon, which is used for connecting to our top-of-rack switches, and we'll talk a little bit about BGP in a second here. And we also use Core DNS too as well. One of the things that is kind of challenging to us in our on-prem environments is that the load balancers are hardware. Cool. Manually configured. Not cool. Same goes with DNS. And so we've tried to put together a system that lets us automate all of this by driving these changes through that configuration agent that is deployed and runs on those hosts, along with these additional services. So let's take a look at this ideal architecture from the standpoint of looking at it from the perspective of a client committing to a service that is on-prem. Just one second here. OK, step one, client resolves the DNS. All right, this is fairly straightforward. Now, what we've done is we've introduced a new global top-level domain within Groupon that is owned entirely by the hybrid boundary. So in this model, we are using split DNS, and so the host name, when the client resolves it, is always going to resolve to a virtual IP in front of the edge proxy nodes that are running within the data centers. So an example of split DNS, if you're not familiar with that, is in the NA1 data center, myapp.production.service may resolve to 10.0.0.1, but then in the EU data center, that may resolve to 10.0.50.1. So same name, different IP addresses. All right, so client has got, it's connected to the on-prem DNS server. Now with that top level domain, it knows to forward that lookup then to core DNS that's running on our edge proxy infrastructure. So it's going to go ahead and return the virtual IP back, and then the client's going to go ahead and establish a connection to that. Now, there are multiple edge proxy nodes here that are in the mix. We have more than one because we want to be highly available. And we're using BGP to load balance across that. And we'll look at that here in a second. Now, you've probably seen the double proxy model before. In this model, we're supporting layer 4 and layer 7 traffic. And we are using MTLS, as I think Michael mentioned earlier, in terms of authenticating connections between services on an as-needed basis. So the local proxy will go ahead and forward out to the remote proxy. This is fairly straightforward. And then it'll complete the connection to the remote service running in that cloud availability zone. All right, cool. So we mentioned earlier that we've got the support agent. And so this support agent is configured to read directly out of this table, or this set of tables, I should say. And it's, again, checking for updates every 30 seconds just to see what's changed and refreshing the position of any edge proxy deployments in addition to the services that are configured to talk across our hybrid boundary. Now, we do replicate that across regions just to make sure that we've got that also highly available. And then that last piece that we haven't talked about yet is Bird. And so with Bird, we're peering with our top-of-rack switches in our data center to using border gateway protocol to more or less distribute traffic coming from different clients around the data center to the edge proxy deployments that we've got, the edge nodes directly, without having a hardware load balancer configured. So in this model, with our support agent powering both the Envoy config as well as the Bird and core DNS config, we're now in a state where we don't have to make any manual changes. Traffic will come in, and it'll be served. Awesome. Now, if we take a look at this on the inverse then, and we look at the cloud to on-prem flow, fairly straightforward and somewhat similar. Now, in this model, we don't need to run core DNS. We don't need BGP because we're able to automate these primitives very simply just by using SDKs and APIs available in the cloud. So if we look at the connection, we see that the client's going to make that lookup against the cloud DNS. It's going to connect to that cloud load balancer, back to the an edge proxy instance, to another edge proxy instance, and back to the service. So again, the support agent is configured identically. It's still connecting back to that database to pull back the tables with the configuration it needs. And in addition, we also have a serverless function that is there listening for events on those tables and updating the cloud DNS and cloud load balancers as needed. Simple, right?
Okay, that's a pretty good design. Let's talk about Gears. Gears is the Groupon engineering architecture review system. This is a kind of internal review we have to do for every brand new project. So a bunch of principal engineers will review the design to make sure it makes sense and it will fit our environment. There's one very important question asked. The question was, do we really want to support TCP services? I will give you a little bit background here. So as you may see, this is a very fundamental change to our current infrastructure. And we created a migration plan. So we divided service by waves. For the initial wave, we found out those services are all using HTTP. So the question came, why do we need to support TCP for the initial release? You know, there are some pros and cons to drop TCP. The pros is like, if we are only dealing with HTTP, we can use the Envoy HTTP connection manager to load balance traffic and route by the host name, which is the new top-level domain we just introduced. And without TCP, we can drop actually BGP. And as you may know, BGP is pretty complicated to configure. Like you have to come up with ASNs and then mess up your maybe core router. That's kind of dangerous to do. And you may encounter some hotspot issue. So that's complicated. The downside of dropping TCP is like we have to find a way to route traffic, which means the existing hardware load balancer. So the downside of that is you have to introduce the manual process, which is not ideal. And personally, I think BGP is pretty fun. You probably don't get a lot of chance to play with it, So set to let it go. OK, this is the components. We don't need BGP, so no more birds, bye birds. Let's take a look at the data flow. This is the original one. Now you can see birds still there. This is the new one. We dropped the birds component, and we introduced the hardware load balancer. So the request, the client will resolve DNS, of course, like before, but instead of connect to the edge proxy directly, the client will talk to the load balancer first, and load balancer will forward the request to one of the edge proxy node. But the rest of the flow is the same as before. The forward request to the cloud edge proxy and finally reach the service endpoint. If you take a look at the other direction, that's exactly the same as before, from the cloud environment to the on-premises. Because in the cloud environment, we don't use BGP at all. We're using the cloud load balancer to route traffic. So there's no change here. But
all right, raise your hand if you like scope change. All right. So we're working on this. We've got our groundwork laid. We're working on implementing the system as we've kind of shown and shared, and a slight change in direction appears. And this came out of a really good conversation that we were having internally. We're all focused on we need to make sure that site reliability is key, right? Uptime equals revenue for e-commerce. And so we're realizing that, okay, well, we're going into this from the approach of, well, if we run 50-50, that's got to be, safer than going all in, right? Well, maybe not so much. We started thinking about kind of what was there in terms of operational overhead, and we realized, yeah, no, we probably should just go all in. And that's what we did. And so with that, we made the decision then that, all right, we're no longer going hybrid. We're going to go all in. And we're going to migrate all of our core traffic to the cloud instead of trying to operate in this hybrid model where we could definitely do it. How well we could do it, I don't know. Ask anybody else who's doing hybrid and see how well they're doing it. All right. So what this meant, though, is that meant that we are now further reducing kind of our investment in our on-prem processes, all right? It's a simpler model after we get done with this transition for our developers and operators. How does that impact us? Well, the ability to weight traffic and shift it over now is way more important because now, we're looking to distribute that traffic across more availability zones because we want to continue to maintain or further improve our geo redundancy. Also, we want to make sure that we're, as mentioned before, we want to do this safely. We don't want to jeopardize site reliability in any way. Now, this led to us start thinking more critically about what we had planned to do. And we decided, maybe we could take a different rollout approach that might be a little bit more painful up front, but in the end, it's going to save us some time and make things better overall for us because we got less cleanup to do. And so we decided, let's just stop deploying on-prem. And so at this point, we have now gotten rid of the need to deploy bird by bird or core DNS because we're no longer going to be leveraging those components. And we don't need Envoy on-prem either. But we kept it in here on the slide, of course, because we're using that on our cloud environments. In this model, instead, we've decided that, hey, all right, we have these well-known interfaces that services are already behind already, the hardware load balancer. What if we just put the edge proxy instances that we have in cloud for the AZs that we want to be distributing traffic to into those load balancing pools? Can we achieve the same thing? And the answer is yes, we can. Now, in this model, what that means is we're no longer changing DNS names. And so we can see that, before we had the lookup to resolve the custom DNS. Now, one of the hidden costs here is that means that we also have to go through each of these 600 microservices to update the host names and make configuration changes. Now, Groupon has a lot of different languages and frameworks in use. It's the kind of thing that can be done, but it's something that takes a lot of coordinated effort across teams because, our team doesn't necessarily own all of the microservices, and we don't necessarily want to work with every single team, to make this change. It'd be a huge undertaking. So, okay, we'll eventually get there, but for V1, let's just use the same name that these load balancers had before. And so in this model, what we do is then we are fronting our remote edge proxy nodes with, again, just a cloud load balancing endpoint. And we are now managing the traffic distribution to these endpoints at the hardware load balancer directly. Now, does this mean more manual process? Yes. Have we failed? No. At least we keep telling ourselves that. But in this model, though, we're now in a position where we can, more seamlessly migrate things over as they're ready to go on a wave-by-wave basis. All right, so let's flip that around, and let's take a look at what this looks like from the other direction. So before, we can see that we had our edge proxy nodes meshed together across all of the availability zones. And now we have our cloud availability zone edge proxies just communicating directly to the service endpoints. And so with some clever subnetting and tricks of the firewall, it turns out it's not that hard to do. And in this case, we managed to cut out a pretty significant chunk of scope as part of this change. So it was a pretty happy accident that we ended up where we ended up at.
Okay, so the current status. Currently, we deployed the hyperboundary project into the sandbox and the staging environment and confirmed the core functionalities working as expected. And now we are actively load testing it and tuning the system to make sure it's ready for the production. So next step. As we mentioned before, we dropped TCP on purpose for the initial rollout. But there are some Groupon services that do use TCP, so we will eventually support TCP service in the later. And the other initiative here inside Groupon is Kubernetes. But currently, the hyperboundary project is designed to operate independently from Kubernetes. And we do want to tighten that. And if you take a close look at edge proxy component, it has all the information or knowledge required to communicate with another service. So edge proxy can route the traffic for you. And if you deploy the edge proxy inside a container, application container or pod, it will essentially become a sidecar. So that way you can reduce the actual hop and reduce the latency. And this looks a little bit like the service mesh architecture. And finally, we do want to evaluate the service mesh. And there are tons of open source implementation out there, and then we'll continuously evaluate. And if some can fit our need, we will adopt that in the future. And I think that's pretty much it. Any questions?
We hit that post-lunch hour slot. No questions.
Yeah, and we are pretty much out of time.
Cool. All right, thank you so much for letting us share our journey with you folks. Thank you.